Hi, let's talk about sorted insert. We are given a linked list and a data item X. We need to insert this item into the linked list such that after insertion, our linked list remains sorted. So we have this linked list 10, 20, 30, 40 and a data item X equal to 25. We want to insert this X in the linked list such that it remains sorted. So where will we insert it? Between 20 and 30. So this is our modified linked list. Let's now see this example. We have a linked list with two nodes 10 and 25. We want to insert 5. So we'll insert it at the beginning because it's smaller than 10 itself. Let's now see this example. We have the data item which is larger than the largest item in the linked list. So it will go at the end. If our linked list is empty, then we'll insert this node and make it head of the linked list. Now please pause this video and write down a function that takes a linked list as a parameter, a data item X as a parameter, inserts the data item in a sorted way and returns head of the linked list. Please note that we need to return head of the linked list because this function might modify the head. We need to change the head when item to be inserted is smaller than the smallest or our linked list is empty. In both these cases, we need to change head of the linked list and return the new head. Let's now talk about the approach step by step. We begin our current from here. We notice that current's next data is smaller than 45. So we move current to the next position. Our current comes here. Now we again notice that current's next data is smaller than 45. So we move current here. Now we again notice current's next data is smaller than 45. So we move current to the next node. We move current here. At this point, we realize that current's next data is greater than 45. So we stop at this point. So we find the previous of the node where we need to insert the new node. So we create a new node with value 45. And now what we do is we make this new node, say this is temp. We make temp's next equal to 50. Temp's next equal to current next and current next equal to temp, right? So once you have found the current, what you do is you do temp next equal to current next and you do temp current next equal to temp. That's how you insert in the middle after a current node. Now please pause this video and try to write down complete implementation. Let us now talk about the complete implementation. In this implementation, we are having some corner cases to be handled explicitly. And then we have the logic that we just talked about. We have a current pointer or current reference that begins from the head. We run a loop while current.next data is smaller than x, right? This is the logic we talked about just now. And after we come out of the loop, current refers to or points to the location which is before the location where new node is to be inserted. And after that, we simply do temp.next, where temp is our newly allocated node. We do temp.next equal to current.next, and then we do current.next equal to temp, right? So this is the logic we talked about. Let's do a quick run for this logic, and then we'll talk about corner cases. So now we want to insert 25 here. So we begin current from here, right? So if you see this data, this linked list and this data to insert, it will not go into the corner cases because head is not null and x is not smaller than head's data, right? X is actually greater than head's data. So it will not go into both of these corner cases, it will come here. And when it comes here, what are we doing? We are simply initializing current as head and then we are running a loop which says that while current's next is not null and current's next data is smaller than x, keep running the loop. See, whenever we access something's dot data or something dot next, we need to ensure that this something is not null. Otherwise, there will be problems. That's the most important thing to remember in linked list questions. Since we are accessing current's next data, we need to ensure that current's next is not null. Also, we need to ensure that current is not null. That we have ensured by writing this condition for corner case. Like if head is null, we won't even proceed further. So since we have this condition, it is sure that current is not null when we came here, right? So current null is handled by this, but current.next or current arrow next not equal to null must be checked. So let's do a rerun of for this linked list. So current begins from the head, current's next is not null, and now we want to insert 25. So we'll compare current next data with x. So 25 is greater than 20, so we are going to move current ahead, right? Current is going to come here. X that we want to insert is 25. So now we again check for this thing that current's next data is smaller than x or not. It's not smaller, right? X is 25 and this is 30. So we have current pointing to or referring to the node after which we need to insert the new node 25. So we have already allocated memory for the new node here, right? This new node is already allocated here. We have this 25 in our temp node and we have hold of this in temp, right? Temp is here. So what are we going to do now? We are going to do temp next equal to current next, right? Current next is this and we are going to make it temp next. So temp next is going to become 30. This 25 next is going to become 30. Now what are we going to do? We are going to change current next also. Current next is currently here and now current next is going to become this, right? So this is how 25 is inserted. Now a quick question for you. If I reverse these two statements, would it still work? If I do current next equal to temp and then current temp next equal to current next, it will not work. If we reverse these two, what will happen? Current next, which was referring here, will now become this. And now we lose track of this node and maybe nodes after it. We completely lose that part of the linked list. So we need to follow this order only, because if we reverse the order, then we do not have hold of this. Now if I reverse it and if I do current.next equal to temp and then if I do temp.next equal to current next, what will happen? Temp.next or temp arrow next will become temp itself, right? Because current.next is also temp. So that's the problem. That's the important thing to remember. We must follow the correct sequence when we are doing linked list questions. Let's now talk about the case when the node to be inserted is inserted at the end. So again, it's not one of these two cases, but this is a special case of this part because it's not smaller than head and head is not null. So we are going to begin a loop which begins from here. We are going to compare current's next data with x and current's next data is actually smaller than x. So we are going to move current ahead. And again, current's next data is smaller than x, so we are going to move current ahead one more time. Now, when we come here, we notice that current next is null, right? So this loop will not continue. This loop will break when either this condition becomes false or this condition becomes false. So this first condition becomes false in this example, so we come out of the loop. And what are we doing after coming out of the loop? We are saying temp next equal to current next. So we already have a node for 35. And we are saying its next is going to be the same as next of it. Next of it is what? Null. So next of it is being updated to null. Right? It was anyways null, right? And after that, what we do? We do current next equal to temp. So we have current next equal to temp. Its next was earlier null. Now it becomes temp. So this case is also properly handled. We have temp next as null and current next as temp. Let's now talk about corner case where linked list is empty and we want to insert a node with value 5. So this is in C++ and this is in Java. So how do we insert in this case? What are we doing here? We are simply first allocating memory for 5 and having a reference or pointer to it in temp. Now we are checking if head is null and this is true for this example. And what do we do in this case? We simply return this temp. So this function is supposed to return the correct head of this linked list. If this linked list is modified, if head is modified, then it's going to return the new head. Otherwise, it's going to return the old head. So in this case, it's going to return new head. So we return temp and this case is handled. We have created a node and we have marked this as head by returning it. Let's now talk about this corner case where we have x is smaller than head's data itself. So in this case, what are we going to do? The first thing that we do in this code, we allocate memory for temp. So temp is here now. And after that, we check for this corner case. Head is null? No. X is smaller than head's data? Yes, it is. X is smaller than head's data. X is 5 and head's data is 10. So in this case, what we do is we simply make temp next equal to head. So this becomes next of it. And after that, we simply return temp, right? Since we are inserting before the head, we make next of it as head and we return this particular node as new head. So we have handled this case as well. Let us now talk about time complexity of sorted insert. Time complexity depends upon the position where we are inserting. If we are inserting at the first position, then it's constant time. If we are inserting after the last node, then it's going to be theta n, where n is the total number of nodes in the linked list. In general, we can say if we are inserting at position pause, then the time complexity is theta of pause.